The next technique that we're gonna study is gonna be the integral of the power of tan and secant that I mentioned earlier in the previous video. So you like to integrate tan to the mx secant to the nx dx. This one is a little bit trickier than the previous one that you have integrate sine and cosine. Okay, for the integral of the product between tan and secant, the first one that we're going to begin with is going to be the power of tan is odd. When you have the power of 10 is odd, what does it mean for the power of 10 is odd? You see that the power of 10 here is 3, the power of 10 here is 5. The trick will be you're gonna just write down, okay, so you have 10 qx, this one can be 10 square and 10x. Okay, so you have 10 square and 10x, and you're gonna let u to be sec x. So it's gonna be kind of opposite, like I said, sine opposite with cosine, cosine opposite with sine. And for 10 here, when you have 10 odd power, you're gonna let u to be sec x. Okay, and you're gonna try to find the term sec x tan x dx. Okay, so you can try to find the term sec x tan x dx. Uh, you're gonna have tan square x, okay, and you're gonna have sec to the 3 half, so it's gonna be sec to the 1 half x, sec x tan x dx. Okay, so this is what you have. Okay, so you get everything that you have, right? So you have 10 cubed, which is this 3 term, and you have sec to the 3 half. So this one is sec to the 3 half. Okay, so this is all you have. And the thing that you see is going to be this one is sec x tan x dx that I asked you to find first. And then why do we need this term? Because you're gonna let u to be sec x. Okay, so you're gonna let u to be sec x. So you're gonna compute du. So it's gonna be sec x tan x dx. Okay, so you're gonna let du to be sec x and you're gonna compute du. You get sec x tan x dx. So this one turned out to be du. Okay, so this one turned out to be du. And also, what is tan square? So what is tan square in this term? So tan square is secant square x minus 1. So you see that you have u equal to sec x, right? So you have u equal to sec x, and you be able to change everything in terms of secant. Okay, so you have u equal to sec x, and you see that you be able to change everything in terms of secant, and you have du equal to sec x tan x. So this one, if you write this one down, it's gonna be integrate. So tan here is gonna be u square minus 1. So this one is the orange term. Okay, so this one is u square. And you have secant to the 1 half, so it's going to become u to the 1 half. So this one is the blue term. Okay, so this one is the blue term. Okay, so u to the 1 half. And you see that the final term will be your du. Okay, so you see that everything turned out to be in terms of u nicely. This one is u to the 1 half, and here this term is u squared. So you have everything in terms of u. So you'll be able to integrate now. So it's going to be integrate u to the 5 over 2 minus u to the 1 half du. So we begin the substitution and you end up with u to the 5 over 2 minus u to the 1 half du. By the way, don't forget to integrate. Okay, so you need to integrate to obtain the final answer. So u 7 7 over 2 minus u to the 3 half 3 over 2, okay, and u plus c. And for final answer, you're gonna put u equal to sec x, okay, so u equal to sec x. So in this case, it's gonna be 2 7, and you have sec x to the 7 over 2 minus 2 third sec x to the 3 half and u plus c. Okay, so this is how we obtain the final answer in terms of x. Okay, final answer will be in terms of x. The next one, you have 10 to the fifth x. Okay, so you have 10 to the fifth x. You're gonna play with this simple rule. So you have 10 to the fifth, right? So the thing that you see first is gonna be 10 to the fifth, and this one can be written as 10 to the fourth x times 10x first. Okay, so it's going to be 10 to the fourth x times 10x. And you recall that we used to play this trick before. You not be able to do anything with 10 to the fourth, but what is 10 to the fourth? It's going to be 10 square raised to square. Okay, so it's going to be 10 square square like this, and it's going to turn out to be 10x dx. Okay, so this is what you will do. And then what? And then you're gonna write this guy as you have 10 square x square and you have 10x. However, like I told you before, we need sec10, okay? We need sec10. So in order to obtain sec10, we don't have sec anywhere here. So you're gonna just multiply with sec and divide with sec. Okay, so you just multiply sec on top, multiply sec on the bottom, so you end up with the same thing, and you just write down dx. Okay, and so you gonna have, what is 10 square? So 10 square here, like I told you, these topics involving a lot of algebra. So you have 10 square here. It's going to be, what is 10 square? 10 square is going to be sec square x minus 1 square. Okay, so this one will be this guy. Okay, and you have 10x, so it's gonna be sec 10. Okay, so sec 10. Okay, and you're gonna have sec x, and in this example I will let you to be sec x. Okay, so let you to be sec x, and you get du is equal to sec x 10x dx. Okay, so du equal to sec x 10x dx, and you're gonna have du to be this term. Okay, so this term turned out to be du, and u equal to sec x, so u equal to sec x. So you get du on top, and on the bottom you have sec x, so it's going to be u, and this is the green color. Okay, so you see I plug in with the same color as the previous line, and then you're gonna just plug in u equal to sec. So it's gonna be u square minus 1 square du over u, and you may simplify this guy to be, okay, so you may simplify this guy to be integrate. Okay, so integrate, so you get u to the fourth minus 2u square plus 1 over u du. Okay, so you get integrate u third minus 2u plus 1 over u du. Okay, so in this case you get u to the fourth over 4, okay, minus integrate to u, you get u square, integrate 1 over u, you get log absolute u plus c. Okay, and you're gonna put u equal to, okay, so u equal to sec x. Okay, so we have u equal to sec x. So this term will be sec x to the fourth over 4 minus sec square x. Okay, minus sec square x plus log absolute sec x, and u plus c. Okay, so this is the final answer. So this question seems a little bit longer than the previous one because of you may have to do the expansion. Okay, so the expansion that we do is quite simple. Expansion here. So you see this one is u minus 1 square, and this guy turned out to be 3 term here. Okay, so that you expand it out and you obtain the final answer in terms of x. Okay. The next one, if the power of the secant is even, okay, if the power of the secant is even, the thing that we're gonna be is gonna be, you're gonna let u equal to 10x. Okay, so you're gonna let u equal to 10x because when you dip 10, you get sec square. So we're gonna try to find sec square together with dx, so that guy turned out to be your du. Okay, and everything turned out to change by using secant square equal to 10 square plus 1. Let's try the first example. So you see this one, I'm not gonna do this question right away. I'm gonna see that this guy can be written as sec square dx. Okay, so it's gonna be sec square dx, and 10 to the 8 is 10 to the 8. You're not gonna touch it. So in this case, you're gonna just write this one as 10 to the 8x. You have sec square x, and you're gonna have 1 sec square together with dx. And for this one, you would let u equal to 10x, and you compute du. Dip tan is sec square x dx. Okay, so this is the thing that we're looking for. So you see that it's going to be du and it's going to be sec square dx. So in this case, you just have integral of u to the 8, u to the 8, and you have sec square. So sec square will change to 1 minus 1 plus 10 square x. Okay, so sec square is 1 plus 10 square x. So this guy is 1 plus u square. Okay, so this is what we have so far. And the yellow guy is du. Okay, the yellow guy is du. So this one, we have the substitution. Substitution. Okay, so we do the substitution until we get this one. And it's turned out to be very simple. So it's going to be integrate u to the 8 plus u to the 10 du. And for this one, it's going to be just u to the 9 over 9 plus u to the 11 over 11 plus c. So final answer, what is u? U is 10x, right? So u is 10x. So you're gonna plug in 2u here. So it's gonna be u and u here. So it's gonna be 10x to the 9 over 9 plus 10x to the 11 over 11 plus c. Okay, and that's it for this example. Okay, the next one gonna be a little bit longer than the one that I did for number one here. Integrate sec to the 6x. So for this one is sec to the even power. And like I told you, we need to change this one into sec to the fourth x multiplied with sec square x because we need this sec square together with dx. Okay, so we need sec square together with dx because we're gonna let u to be 10x. And you compute du, so it's gonna be secant square x dx. Okay, and this guy turned out to be du nicely. And you have sec to the fourth. Okay, so you have sec to the fourth. Again, sec to the fourth, you not have identity for it. Okay, for sec to the fourth, you not have identity for it. So you're gonna get sec square square. Okay, so you have sec square square. So for this one, it's gonna be integrate sec square x square. Okay, and you get sec square x dx. And for this guy, okay, so you're gonna have sec square turn out to be du. Okay, so this one quite simple. And for sec square for this term, it's gonna be 1 plus 10 square. Okay, so for this one, it's gonna be integrate 1 plus u square and du. Okay, so this is the orange term. Okay, so this is the orange term. And then you expand this one. So you expand, it's going to be 1 plus 2u square plus u to the fourth du. And don't forget to integrate. Okay, I said before, don't forget to integrate. And you're gonna integrate 1, you get u, integrate 2u square, it's gonna be 2u cubed over 3, and integrate u to the fourth, it's u to the fifth over 5, and u plus c, okay, and you have, okay, u equal to 10x, okay, and for this one, it's gonna be 2/3 10x to the third plus 1/5 10x to the fifth plus c. Okay, so that will be the final answer. Okay, because your u equal to 10x. Okay, so your u equal to 10x. Okay. The last one that you have is going to be the power of 10 is even and the power of secant is odd. So we kind of the complement of the previous two cases. Okay, so the power of 10 not odd, the power of secant not even. What should we do? The thing that we're gonna do is gonna be we're gonna try to express everything completely in terms of secant. Okay, so you're gonna see that if you express this guy completely in terms of secant, let's do example. So you see 10 square, okay, so you not be able to split anything, so you're gonna be just write this one as secant square x minus 1 and secant x dx. So this guy is the yellow guy. Okay, secant square minus 1 equal to 10 square. And you see that you end up with integrate secant to the third minus secant x dx. And for this one, we learned this one before. This one you use by part. Okay, so this one is on page 14. Okay, so you go back to page 14. So this one is on page 14 and you just use by part and you integrate sec x. Okay, integrate sec x, you'll be able to get just the formula. So this one is going to be log absolute sec x plus 10x. Okay, So for this one, I say that if you like to integrate the power of 10 is even and the power of the secant turn out to be odd, you just change everything in terms of secant by using 10 square equal to secant square minus 1. You'll be able to do that because you are in this case. And you're gonna just discover that you may have to use by part in order to integrate. For example, you're gonna integrate sec cube, you have to use by part. If it turns out to be sec to the fifth, again it's by part. Okay, so that will be by part. And you we did this one on page 14 already. So let's just write it down. So you just have integrate 1 over sec x, so it's going to be what? It's going to be 1/2, and you get sec x tan x, okay, plus log absolute sec x tan x plus tan x. Okay, so this is the term that we have here from page 14. Let me change the color to the gray one. Okay, and you're gonna add by the green one, so it's gonna be adding by log absolute sec x plus tan x, and then finally you're gonna plus c, okay, for final answer. Okay, so for this one you get 1/2 sec x tan x, okay, and you have these two guys. I have the mistake on my side, it's minus sign, sorry. Let me emphasize this side a little bit. This is a minus sign, okay, and you would get 1/2 sec x, and you have 1/2, so you're gonna get negative of 1/2 sec not sec, log absolute sec x plus tan x plus c. Okay, so this is how we integrate. Okay, for last conclusion, so you have sec to the mx, tan to the nx. So you have three cases. The first case is n is odd. Okay, n is odd, you're gonna have u equal to sec x. If m is even, you're gonna have u equal to tan x. Okay, so if you memorize this way, and if you have m is odd, n is even, you're gonna use by part. Okay, so this is the thing that I like to conclude for integrate the power of secant and tan. Okay, so it's gonna fall into three cases, and you need to memorize the techniques. So you need to memorize the technique separately. Okay, so far what do we be able to do? So the thing that we be able to do turn out to be you be able to integrate the power of sine and cosine, the power of tan and secant. Okay, the next one will be just if you want to integrate the power of cotan and cosecant, the same thing happen. Okay, so it's gonna be the same thing. Okay, and it's gonna be can be found by similar method because of integrate of cos and sine. The identity for cotan and cosecant turn out to be just this identity similar to secant and tan. Okay, so you see that this one can be correct a little bit. So if you have cosecant to the mx and cot to the nx. So you have the same thing, but in this case, you will be cosec, okay? And in this case, you will be cot x, okay? And you use by part. Okay, so you see that it's going to be similar technique for cosecant to the m time cotan to the n. Okay, so this one I'm gonna say it's gonna be same thing. I'm gonna show you one example and we're gonna stop here. So we have integral of square root cot x cosec to the fourth. Okay, so you have even. So you have cosec even. So cosec even, you're gonna write cosec square multiply with cosec square. Okay, so this is what you have to do. So it's gonna turn out to be integrate square root cot x. Okay, and you have cosec square x one term together with you have cosec square dx. Okay, so I have cosec square x dx. So this guy is the yellow one. Okay. And then you're gonna let u, okay, so here it's gonna be even for m, okay, m even, okay, so m even. So it's gonna be, you're gonna let u equal to cot x. Yeah, so you're gonna let u equal to cot x, and you have du equal to negative cosec square x dx, and this guy, okay, will turn out to be negative du. Okay, so here be careful a little bit on the negative side, and you have cosec square. Cosec square turn out to be 1 plus cot square. Okay, so it's 1 plus cot square. And you have u equal to cot x. Okay, so you have u equal to cot x. So this guy and this guy. So you get integrate square root u and 1 plus u square. So this is u, this is u, okay? And you have negative du, okay? So it's going to be negative du, okay? So it's going to become negative integrate square root u plus u to the 5 over 2 du. So it's going to be u to the 3 half over 3 half plus u to the 7 over 2, 7 over 2 plus c. And finally, you would get u back. So it's going to be negative 2/3 cot x. Okay, so here u equal to cot x that you're gonna put back. Okay, so u equal to cot x. So it's going to be cot x to the 3 half and 2 7. You have cot x to the 7 over 2 and plus c. Okay, so this is how we obtain your final answer. And make mistake on parentheses, right? So it's going to be negative side, and negative side. Okay, yeah, that's all. So you see that this one is the final answer, and it's gonna turn out to be similar to the secant and tan. Okay, so you can try by yourself. You can just use this example. Okay, you just use these two example. You can just use these two example. You change tan to cot, you change sec to cosec, and you change sec to cosec, and you're gonna proceed by the same way. However, be careful on the minus side. The thing that you will obtain and unexpected turn out to be this negative side. Okay, so that negative side turned out to be kind of annoying a little bit. Okay, when you calculate this one, and if you miss the sign, you're gonna miss the correct answer. Okay, so I gonna stop here. This is the thing that I teach you so far now is called trig integral, and we're gonna apply them in order to do the trigonometric substitution in the next topic. Okay, so that's all.